This is our first lesson in the next part of our quadratic equations unit. So this is unit 6, and we're going to focus on simplifying radicals. So our central question is, how do I simplify radicals, meaning square roots, using perfect squares? So the first thing we're going to do is take a kind of look at our rules here. So here are going to be our rules. Find all the perfect squares, and we're going to factor them out. So think of it almost like a factor tree. We're going to pull apart the number using some perfect squares. And then when there are, and we want to make sure that if it's a fraction that we don't have any radicals, any square roots left in our denominator. And we'll get to that a little bit later in the lesson. So we're going to try to pull out any perfect squares that we can, and then try to see what's left over with the rest of the problem. So on the left-hand side of our notes, we're going to fill in these very important perfect squares. Okay, these should be the ones that are just common knowledge for us. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 49 for my 7s, for my 8s are 64, my 9 is 81, 10 is 100. And let's even add in the next couple. 11 squared is 121, 12 squared is 144, 13 squared is 169. The better you know those perfect squares, the easier this next part is going to go for us. All right. Now, go back up to question 1. So the idea is, how can I split 18 into pieces so that one of the pieces is a perfect square? Well, 18 is really 9 times 2. So I break it into 2 pieces. The square root of 9, well, that's a perfect square. That's 3. I don't know the square root of 2. That's not going to be a whole number. It's not a perfect square. So it just stays 3 square root of 2. So we're basically pulling out as much from the radical as we can, but it's not always going to be everything. But we're trying to divide out as many perfect squares to simplify what's left in that radical. So 24, well, what could I multiply? So always think of the perfect square first. What perfect square goes into 24? Well, that would be 4 times 6. The square root of 4 is 2. Square root of 6 is just square root of 6. So next one, number 3, square root of 160. So there's a couple ways of going about this one, but you look for what you can find. So some people might do it as the square root of 4 times the square root of 40, and then we could break that down farther. Some of you might see a 16. Well, that's a perfect square, times the square root of 10. Square root of 16 is 4. Square root of 10 is just square root of 10. And then last one, square root of 17. Well, 17 doesn't have any perfect square factors, so it just stays square root of 17. But here's one of the little notes. You'll notice that when we're doing this, we're always coming out with a positive version. That's called the principal square root. So when we just see the square root symbol of a number, we just want the positive version of it. Okay, square root of 16 is positive 4. If we want both square roots, the positive and negative, you'll see it written like this. So when we see the positive and negative in front of it, there we want both the positive 4 and the negative 4 for our square roots. But if we see just the square root of a number, we just want that positive number version of it. It's called the principal square root. Okay? All right, so these are for you to try. Okay, so pause it, try a couple for yourself, and then hit play and then see what I got. So here I'd break this into square root of 4 and square root of 5. So I get 2 square roots of 5. That one we already did on the front. 40 is really square root of 4 times square root of 10. So 2 square roots of 10. Square root of 10 doesn't have any common factors, so I just leave it as square root of 10. Next one's a little trickier. What can go in 50? Well, I can do 25 times 2. But those are both still in square roots. They're both radicals. Now I find the square root if I can, and I get 5 square roots of 2. Okay. So 300, well, that's the square root of 100 times the square root of 3, which gives me 10 square roots of 3. Okay. So for instance here, this would be the square root of 9 times the square root of 3. So that's 3 square root of 3. 28 would be square root of 4 times the square root of 7. So 2 square roots of 7. Okay. 48 can be done a couple of different ways. So I could do square root of 4 times square root of 12. Well, square root of 4 is 2. Square root of 12 is square root of 4 times the square root of 3. So I can simplify it farther. And that gives me 2 times the square root of 3, or 4 square roots of 3. Or maybe you notice that actually 16 could come out of 48. So I could do square root of 16 times square root of 3. That gives me 4 square roots of 3. So notice I get the same answer no matter how I broke it down. Okay. And then the last 3 real quick. So square root of 9 times square root of 10. So square root of 9 is 3 square roots of 10. 98 is a little tricky, but this is actually 49 times 2, which is 7 square roots of 2. And then 63 is square root of 9 times the square root of 7. So 3 square roots of 7. So we break them into pieces using a square root as one of our factors. We find the square root of that perfect square, so we can turn it into a whole number, and then the piece left in the radical remains. All right, so what do we do when there's a number out front? Well, that number just gets multiplied times whatever comes out of our radical, okay? We just keep simplifying it as far as we can. So here I have 2 times the square root of 9 times the square root of 2. Well, square root of 9 is 3. And then 2 times 3 is 6 square roots of 2. Here, negative 4. 12 is negative square root of 4 times the square root of 3. Square root of 4 is 2. Times negative 4 is negative 8 square roots of 3. Number 3, so I have 6. For 72, that's the square root of 9 times the square root of 8. Well, square root of 9 is 3 times 6. But square root of 8 is square root of 4 times the square root of 2. So now I have 6 times 3 times 2 times the square root of 2. Or 36 square root of 2. Or you might have noticed that this is 6 times the square root of 36 times the square root of 2. Okay, because 36 times 2 is 72. So that square root of 36 is 6. So I get 36 square roots of 2. Notice I get the same answer whether I break it down all at once or whether I do it a piece at a time. So 1/2 times the square root of 4 times the square root of 5. Square root of 4 is 2, so 1/2 times 2 times the square root of 5. 1/2 times 2 is just 1, or just square root of 5. Here I got 10 times the square root of 16 times the square root of 2. Square root of 16 is 4, times 10 is 40, square root of 2. Next one, 48's come up before. Remember that's square root of 16 times the square root of 3 times my negative 2. So that's a negative 2 times 4 times the square root of 3, or negative 8 square root of 3. So we just have that extra number getting multiplied out front whenever we have it. So here, negative 1 times the square root of 4 times the square root of 11. Square root of 4 is 2 times negative 1 is negative 2 square root of 11. Here, 3 square root of 13. Well, square root of 13 doesn't have any perfect square roots, so it just stays square root of 3 square roots of 13. Here, I've got 5 times the square root of 100 times the square root of 5, because that makes 500. Square root of 100 is 10 times the square root of 5 times 5, or 50 square roots of 5. All right, so hopefully you got the idea of how we factor those pieces out.